So welcome students. So in this question, you're asked to find the perimeter of the locus represented by argument of z plus I by z minus I is equal to pi by 4. So this is a question based on rotation theorem in complex numbers. So first let us try to understand the background of this question. So argument of z minus z1 by z minus z2 is equal to theta. What is the meaning of this from rotation theorem? So you have a vector, a complex number z, you have a complex number z1, you have a complex number z2. So what you need to see is you need to find the vector z minus z2. So a bar minus b bar gives the vector ba. That is, this represents a vector going from z2 to z. That is this vector. And z minus z1 is a vector going from z1 to z. That is this vector. So the numerator represents the final vector. The denominator represents the initial vector. So what is the final vector? Z minus z1. This is the final vector. Z minus z2 is the initial vector. Now the argument of this complex number is nothing but the angle which we get by going from the initial vector to the final vector. That is, this angle has to be equal to theta. So the meaning of this is argument of z minus z1 by z minus z2 is equal to theta means that z, z1 and z2 create a figure like this. That means z is moving such that this angle is constant. And this angle has to be taken with sign. Keep that in mind. That's going from initial vector to final vector. If the angle is in clockwise direction, you have to take theta as negative. If the angle is in anti-clockwise direction, theta is positive. Now let us apply this to our given question. What does this mean? So this equation means that argument of z plus I by argument of z minus I. So you have two vectors, I and minus I. So what is my z doing? My z is such that what is the initial vector? Initial vector is the vector joining I with z. So let us say that this is my z. So initial vector is the vector joining from I to z. So that is this vector I to z. And the final vector is nothing but this is z minus of minus I. That is a vector joining minus I to z. So this is my final vector. This is my final vector. This is my initial vector. And what is the angle that initial vector makes with the final vector? This is the angle. So this z is maintaining this angle to be pi by 4. So in that case, what is the locus of this z? So what is the locus of this z which maintains this angle to be equal to pi by 4? So obviously this has to be a arc of a circle, because we know that if this is pi by 4, this is also equal to pi by 4. Z is moving such that the angle made by I and minus I at this point is always equal to pi by 4. Hence, this represents a segment of a circle. So let me see what that circle is. So if I have I and minus I here, so you have Z such that this angle is equal to pi by 4. Z such that this angle is equal to pi by 4. So Z can lie on a segment of a circle such that the chord makes an angle of 90 at the center. The chord has to make an angle of 90 at the center. If that is so, the angle in the segment will be 45 degrees. So Z can lie on any point of this sector, wherever Z is. So you have angle to be pi by 4. So you'll get a segment. So this angle obviously looks more than pi by 4. So Z lies a little outside. So you have the locus as something like this, a sector. So you won't get this side. You won't get the sector on this side, because if you take the sector on this side, so what is the initial vector now if you have Z here? So the initial vector is the line joining I with Z. So this is the initial vector. What is the final vector? So this is the final vector. So if you go from initial vector to final vector, the angle as you see is in clockwise direction. That is, this angle is minus pi by 4. So if I take this as minus pi by 4, then I get this sector. If I take it as plus pi by 4, I get that sector. So what is the radius of this sector? So what is the radius of this sector? So the radius is, as you can see, if the radius is r, this angle is 45 degrees. This angle is 45 degrees and this is 2 units. So this has to be 1 unit and 1 unit, because this is the origin. Distance between origin and I is 1 unit. So if this is 45 and this is 45, this is also equal to 1. So 1 implies r is equal to root 2. So the radius is root 2. So the perimeter of total circle is pi r square. And what is the sector? How much part of circle is the sector? So can you see that this is 3/4 part, because this is 90 degrees. So this angle is equal to 270. So if 360 degrees represents complete circle, 270 degrees represents 3/4 of the circle. So perimeter is nothing but 3/4 of 2 pi into r is root 2. So this 2 gets cancelled. So 3 root 2 by 2 pi is the perimeter of the required locus. Thank you.